Good morning, sir.
Good morning, sir.
Very good morning.
Okay. Good morning, all of you. Good morning, Shanmugh sir.
Good
Good
morning,
morning,
sir.
sir.
Good morning, sir.
Good morning, sir.
Morning.
Good morning, sir. Good morning, sir.
So,
Good morning.
yeah, good morning. So today we are starting a new concept that means we're just moving aside from scratch, and I think we will also continue with scratch in different levels. I will also ask you to do few things if really possible. Uh, so before moving to Raptor tool, we need to discuss about few things that are all the principles of programming.
Sir,
Yes.
I am ready with the project for the evaluation.
Yes, okay, fine. This time I'm doing the evaluation in the lab only, okay? So not now. So we are going with the concepts in the theory class, and in the lab on Friday, I will evaluate all the remaining projects, okay? For the
On
scratch.
Friday, sir.
Yes, on Friday.
Okay, sir.
Yeah, right. Okay. So now, this time we are moving into the principles of programming. So one thing we always discuss is programming language is not very important, but the principle of programming is very important. The reason is the analysis of the problem, how you decide the solution is really important here. So, for example, you talk about solving a case, how the police will analyze a problem, how do they take a decision on who is the criminal. So most people will ask, sir, if I learn Python, will I get a job immediately after my BTech fourth year? But I always say learning Python or learning Go language, which might be the newer language at this generation, for this generation, will not give you or fetch you a job. The only thing that people will see in you is how you analyze the problems, how you find out the best solution, and
Alert
effortful
from
solution. 1 minute.
your disk.
Okay, so if you can find a very good and affordable solution from your side, I think you will be the best person to get selected. The recruiters will only see whether you are grasping or not. For example, you learn how you can store a memory, what is an integer variable, what is a float, and what is a character, what is a string, some basics which are common to C, C++, Java, and Python. And you also learn how you write a program, how you write in a very affordable way. So you must think that the number of lines of code are very important in software industry, because the number of lines of code will increase the cost of producing a software product. Okay, they also need to give high salaries because you have produced 1,000 lines of code. For 1,000 lines of code, they need to calculate how much give you the salary. So people will start. See, it is showing your internet is unstable for me. Is it audible?
Yes, sir.
Okay,
Audible.
what I am
Yes,
talking
sir.
is
Breaking
audible,
some
clear?
Lagging, sir.
It's breaking, sir.
It's lagging,
Okay.
sir, a bit.
Yeah, yeah. Okay, right. Is it clear now?
No, sir, it's worse.
Yes, sir.
This is very important. And so you need to understand few things, like how a computer works when you write a program. So how the memory works and how it processes is one aspect, which I am also telling it to you. The other aspect is how you write a program in a very efficient way. So the basic principles of programming should be clearly understandable so that you can go further. So it is like mathematical theorems. So today, the first concept that we go inside is decision making. So I will give you a Google form. This is a very interactive session. We start explaining with, we discuss, I first explain to you what exactly is a decision making with all the diagrams and the content there. And we also discuss some real-time examples of how do people do decision making. Then we go to computers. And the next aspect is, for every concept, I give a small question to you. So the beauty of this interactive session, it works like Coursera. Until unless you put a correct answer from your side, I am passing you the link of Google Form now in the chat. You cannot go forward to the other topic. So you must be putting the correct answer there based on your analysis. Some questions are easy. Some questions might take 1 or 2 minutes. That's all, not more than that. But it tests your interactivity with your class section, so that you are not leaving. By logging in, sometimes people might leave somewhere else. Okay, because okay, he's talking and nobody sees me. So I am preparing for an interactive sessions from this time onwards. So I think this is the first class we are discussing with an interactive section, and also your involvement should be there. So now I'm passing it to you, the link. Now this is the link which I have pasted in the chat. You can access and open this one. So have you all opened it?
Yes, sir.
Yes. Okay. Right. So I will get a form in which all your clicks and your answers will be recorded here, and there are points for this. So you might keep whatever answer you like. So if you want to change again, if it is not coming back, for example, if I give a question like this, if you are unable to answer it, next, and if your answer is not correct, so that until unless you understand the topic, it might not go forward. So please be careful of the question and write it. Of course, the first few questions are very easy. Right. So what is meant by decision making? So until now, you have been in mathematics, not many a time some decision making in mathematics, because mathematics is mathematical calculations that you get finally with some formulas. You normally don't take decision making in most of the mathematical problems. But a related concept of mathematics is computer science, and computer science basically works a lot with decision making. So decision making plays an important part in computers' daily activities. Whether it might be the computer playing a chess, or the computer might be playing, working with the calculator, the computer might be working with bank system, the computer might be working with market system. Everywhere, the computer acts because of its decision making. Why computers? Let us go to our own life, personal life. So we think that okay, in 10th class, if I get more marks in mathematics, and if I am interested in mathematics, I think naturally you will go for intermediate MPC. Or if you are really interested in biology and you are getting good marks in biology in 10th class, because your teacher is saying it good, and you are inspired by the biology teacher or something, because she or he is saying good, so you might join in BPC. This is what a decision making. Again, after MPC, you might be interested in computer science, and based on some conditions, you start working out with some command instructions, right? So, for example, based on your father's interest or mother's interest or your interest, the decision making is very important in our life. That is why some people will say, "Sir, my life is spoiled because I have took a wrong decision." Okay, this is what the decision making is. But computers do not have wrong decisions or right decisions. Whatever you write is what the computer follows. Yes or no, true or false, that's only. It asks you many questions, or you need to generate some questions. For example, you said A is equal to 6 and B is equal to 7. the computer will ask whether compare. It will not ask here, but it will compare like what is A and what is B, whether A is less than B. Okay, if it's A is less than B, then go to the true side. If A is not less than B, then go to the false side. So this is how the computers take decision regarding the logical operations. And also you need to think about, if you go to an ATM, every time a computer asks something, insert your card. If you don't insert the card, after some time the computer will say, no, you are not inserting any card, and so I am quitting. If you insert a card, the next thing is that user has inserted card, so it will ask, please enter your password. If you are wrong, putting a wrong password, then it will go to the false side. If you are putting the correct password, it goes to the correct side. The next question it will ask, what transaction you want. See, every time it is taking decisions based on your inputs and answers. So if you say withdrawal, okay, if you click withdrawal button, it will immediately go to the withdrawal and ask you how much amount of money I need to give. And based on your money, it again takes decision whether this money is eligible for ATM withdrawal or not. Computers work daily using decision making. So you should be writing a program with some effective decision making algorithms. I will tell you in this, by the end of this course, you will know how effective the decision making algorithms. And when we write the first few programs in Raptor, then you will understand how well we can draw the flowcharts with less number of conditions to go to the final answer. Right. Computers can take decisions and computers can do things very, very fast. Right now, a computer can decide what is the solution to a mathematical equation. And sometimes it can also work for a bank in which it can detect who is a fraud customer and who is not a fraud customer. I think the right decisions are very important in this aspect. So you need to detect who is a fraud. You need to detect who is a criminal. Okay. Let us think that you are police and you are trying to solve one greatest problem, a murder mystery. I want to ask you, what is the first question that you ask so that you will minimize the number of criminals to be focused? Can anybody tell me what is the first question you ask as a police officer?
Sir, can you repeat the question?
Maybe gender of
Tell
the
me the truth. Did you do
killer.
this?
We asked them where are they at that particular time, sir, when the crime is
Yeah,
happening.
one minute. Somebody is telling, tell me the truth, but
Sir.
wait 1 minute.
Problem identification.
So I think Sriya has said, tell me the truth, but we did not find the criminal. The problem is there is a murder mystery and you need to find out the criminal. What is the first question you ask with the witnesses? Yeah, somebody said,
Witnesses. I thought suspects.
We will ask where are they, sir, at that particular crime.
no,
Crime
somebody
time.
said at the start the correct answer.
Sir, gender, sir.
When it happened.
Gender is the best question that we have. So eliminating, for our example, we are not taking transgender. Of course, transgender is also now included as one of the genders. You can find out in the applications. So for our example, I will only go for male and female. Okay, because if I go to the third gender, what happens is my example might go wrong. You don't understand. So I want only yes or no. Okay. So the first question the police will ask is whether the criminal is a male or not. So, or the police might ask whether the criminal is a female or not. Generally, females are not suspected. Basically, they will ask, is he a male? Okay, right? We say yes, right? So, I think the female population is entirely eliminated, right? Now, what is the next question that you might ask?
How did it happen?
Yes?
Where did it happen?
No.
Our name and address.
At what time?
How does he look?
Yes,
Our relationship with him.
Relationship with him.
No,
Or
until unless you identify a criminal, you cannot find out the relationship, right?
Sir, his height?
Height.
When
Okay.
it is happened.
address,
Any
his
CCTV
address and his
footage?
name.
Yeah, 1 minute. Height you can put. but I think height cannot divide the entire thing, right?
Yes.
Many people of many ages will have height. And I think I have given you a hint. What can be the next question?
Sir,
Age.
complexion.
Age.
Age of the person.
Age should be the next question. So somebody says he is around 40 years of age. Okay, they eliminate below 40 and above 40 years, 40 to 50, and they coincide between them. Okay, 40 to 50 age will only be taken. And now the data science comes into this part. So I think most of half of the class will be data science here, right? So this is how data science will have a lot of decision making here. So if you want to separate the data, analyze the data, decision making is very important. So what is the next question you ask after gender? So somebody said height. Okay, you ask height, and somebody said features. Okay, next you ask features. And based on
Facial
this,
hair, sir.
facial hair.
His
or-
mannerisms?
Yes, last you will get the mannerisms.
Hmm.
I want the decisions to be taken initially. So you need to eliminate all the stupid questions. You need to bring out the questions which will bring down to our final result as early as possible. This is called the best decision making. If you post something like, for example, if you said what is the age of a criminal, the first question. Imagine that if the police ask what is the age of the criminal, somebody said 40 to 50, and I think both men and women will be between 40 to 50, right? So if he asks the questions before he stays, so there are many people. For example, in 100 crore population, there is 50 crore male and 50 crore women. Okay, so what you do is you divide them. So you only get only 50 crores with your hand. It's what data science. But if you go to China, there are people between 40 to 50. Most of them are old, 40 to 50. Youth are very less. So if 40 to 50, you said the first person is what is the age? If somebody said 40 to 50 is the age, maybe you will get 70 crores of the population who are in 40 to 50. That means you are trying to eliminate only 30 and you are having in hand 70. So what is the difference between 50 and 70? Another 20 crores are with you. So analyzing the person from another 20 crores extra is very difficult. So the question you ask in data science is very important for this particular decision making. Now, all these concepts that we go through in this lesson will always teach you what is the correct one with some example. Okay, an important part of computer science is understanding how computers make right decisions. Is the first concept that you need to understand. The first two explorations of this course, you will learn about how computers use a lot of decision making in order to make complex decisions. So I said many applications are there. For example, the complex decisions might be your chess. Your chess game has a lot of decisions, right? Your mind will take a lot of decisions while you are playing chess. Somebody in this class might be playing chess, right? So chess is also part of artificial intelligence, machine learning, lot of data, and based on the data, it will take decisions. Okay. So one of the ways computers make decisions is with a structure called a decision tree. This word is very important for your data science. So decision tree encode a series of simple yes or no questions. So when you are coming down to the tree to find out the answer, it has a series of yes or no questions that I will show you next. So don't open just your form, keep your form aside and look into the screen. When I say the answer to the question, then only open the form. Okay. And this matter can be later used by you to study for the exams. So here is a very silly decision tree I am showing you. And if I said something like this, you can look into this decision tree. You can take 30 seconds to look into this. So we have few questions like, is it smaller than, you need to identify some animal, and it said that, is it smaller than a bicycle? Is it carnivore? Does it swim? Does it fly? Does it swim? Is it a mammal? Like that. Right? So this is the question we need to pose now. So if a computer were using this diagram while looking at the creature that happened to be an adult blue whale, the computer would start at the top box. What is the top box here? Smaller than bicycle, or it wants to identify the blue whale. So what do you say? Is it smaller than bicycle?
No, blue whale is
Comes down.
No, sir.
First question it asks is, does it swim? The first question it asks is, does it swim? Yes, we want blue whale, so it says yes, it will swim. So we will finally land at the final result, blue whale. Right? This is what we are saying. The computer will follow the no path, the arrow that goes to the right. The next box contains, does it swim? The answer is to be definitely yes. And so finally we landed blue whale after getting through these decision making things. And I want to just ask you, how many times you are asking the same question here? What is the question always repeating?
Smaller than a bicycle.
Bicycle.
What is the question that is having a repetitive
Does
appearance?
it swim?
Does it swim? Yes or no?
Does it swim?
Can't we reduce it in such a way that, see, for example, smaller than the bicycle is having many animals, and greater than bicycle size is having only 2 animals. But I think for every decision, we have one question called, does it swim? So can't we divide it as the first question, does it swim? And so that we can reduce the number of questions that are asked. I think we can reduce the average, average size of the number of.
So your voice is breaking.
Sir, your voice is breaking.
Now, what is the maximum size of number of questions?
Sir, your voice is breaking.
Okay. I don't know why. I'm using my mobile data itself so that it might not break. Yeah. Is it okay now?
yes,
Yes, sir.
Yes, sir.
Yes, sir.
So here, because we are asking the same questions again, this is one thing that is wrong actually. And we can put it in the center, which can be the common question that can be asked so that we can divide between them. And what is the, what we say, the maximum questions that are asked to go to the last one. So that is my question here. Can you answer based on this one? My question is, a computer is using the decision tree. Which of the listed creatures will require the computer to ask most questions? And a creature
Mouse.
find out.
Sir, can I say that it's mouse?
Sir, mouse.
Mouse, sir.
Yes, you put mouse, that's all. So I think you are wasting a lot of energy for a single creature. Why can't we divide them? So your task next, before coming to the next class, is to rearrange this so that the number of questions might be reduced. Take this diagram, rearrange them in such a way that the number of questions, so the maximum question that we have in this decision tree is 1, 2, 3, 4, and 5. 5 questions are there. So to get to either mouse or virus, you need to ask 5 questions. So this is very bad in decision tree. So the number of questions should be reduced as max, because most of the times the computer scientists will always prefer in data science, the data should be analyzed as fast as possible. But if you are not analyzing it as fast as possible and you are going for a lot of decisions in the decision tree, and it takes a lot of time to get to the final result, I think your code is not efficient code. So if possible, you can reduce to the maximum number of decision in the decision tree, the best possible decision tree by rearranging them. Try it out in your home after this. Right. So here, The computer scientist can use decision tree to write simple face recognizer. Okay, so in image processing, we call it like face recognizer. And now I think our CATS department and some of the faculty I was actually interested. I was not attested to it. I was attested to other projects earlier. But now some people are working on facial recognition attendance. That means they take a photo of this class, the camera will be set up. So without your instructor calling 1, 2, 3, 4 like that, every period there will be a click of your photos so that the face will be recognized. Okay, let us look into this person. The computer scientists first write 3 simpler tests to detect glasses, long hair, and open mouth. Okay, in the below faces. The decision tree organizes these simple tests, allowing the computer to distinguish between all the faces. The first question at the very top of the decision tree is an especially important one. This is what I am discussing until now. The first question should be very important because you need to eliminate the maximum possibility to your side and the other impossibility to the other side. So, for example, if you have 4 faces, I think you need to write a question in such a way that at least you need to get 2 divided. You should not divide with 3, 1, so that you have in your hand 3, which you need to analyze, take some other decision making questions. I hope you are understanding. అంటే మనం ఒకసారి డెసిషన్ తీసుకున్న తర్వాత మనకి గనుక maximum data వస్తే, then that data will not be very useful to us. We need to get at least the minimum data or half of the data so that we can analyze it step by step. We can divide them into number of halves. So that makes your complexity also reduced. It will go to log n complexity because it is 2 power I, right? So when, for example, 4 are there, you divide into 2. When 2 are there, you divide into 1. So you are dividing into half. It looks like a tree that you can later on understand. So the first question at the very top of the decision tree is especially very important, which can land you with few questions to the final result. Imagine that you want to make a decision tree to distinguish 4 faces below. If you want the root of the decision tree to split the faces into 2 groups, which of these questions would you ask?
Open.
Is their mouth open?
Depends
Is their
upon
mouth
mouth open.
Long hair.
Long hair.
Their mouth open.
Mouth open. Mouth open.
Their mouth open.
sir.
Is
Listen,
their mouth open, sir?
first take 30 seconds, put down your answer, and then tell me the answer because I have to give all.
Sir, mouth open, sir.
Yeah, that's what I'm saying. First take 30 seconds at least and put your answer calmly, and then you can say the answer because all have to put the answer. So why are you saying mouth open?
Sir, because it
It was
is
split
Divides
into
the
2.
task into 2.
2 parts.
Yes, that's good. Let us go through. Right. Okay, your answer is correct. So above question in your decision tree will split the faces into 2 distinct groups, right? So what is the single question that you could ask among these 2? Now I want to identify the final face. The open mouth, and so if the open mouth is there, you go to S, and there is no open mouth, then you go to the second one, the right side one. If this is open mouth, so I want to ask you, hey, somebody please shut your mouth, mic, not mouth. There are some things that are going on back side. అంట్లు గడుగుతున్నారా అండ్ క్లాస్ వింటున్నప్పుడు it disturbs the class. You need to look into the mic. Okay, fine, sorry for the disturbance. So I think if it is S, you go to the left side, and if it's okay, you go to the right side. Fine, but now our final decision is, how do you identify a single face? For example, I want this woman with glasses. Maybe I want this man who is laughing. So how do you identify? Which of the below questions you identify so that both things will be common?
Are they
Do they have long hair?
Both
Long
together
hair.
we can Fine, sir. Individually, we can ask.
Individually.
What is that individual? If somebody said
Are
that,
they wearing pink
For
glasses?
individually, it's like a long hair and pink glasses, sir.
So I think there is no common question for both the categories. To
Yes,
identify.
sir. There is no common question.
So I think your answer should be none
None
of the.
of
None of this will work.
Now, so none of the choices you are giving are able to further split up both the groups. So you can nevertheless make a decision-making tree that distinguishes all the four phases with different questions, as you said. So somebody said like long hair, that can divide them between, or you can also say men and women, or you can also say other thing like eyes closed and eyes open. Any question you can pose. And the other thing we see, because both mouths are closed and both are having long hair and both eyes are open, the only question that remains here is pink glasses. So definitely you need to ask whether you are having pink glasses or not. But here you need to ask any question. That's your wish, whether long hair or man or woman, like closed eyes or open eyes, like that. So the shape of the decision tree can make a big difference of what happens when you use it. For example, you take this one. Your computer program is using a decision tree. How many questions on average will the computer program need to ask and answer in order to distinguish the random phase? So, this random phase cheyadaniki meeku on an average inni questions adugutundani cheptundi?
3.
3, sir.
3, sir.
Is 3. Can't we reduce it further?
No, sir.
I think we can reduce it a little further, or I will also say it might be the best one. It might be the best one because on an average, for all the people who are to be identified here are being identified with only 3 questions. Antakumundu example chusara?
Yes, sir.
Yeah, in that example, to identify 2 or 1 object, we are having long number of questions, like 5 questions or 4 or 3. That's completely a bad decision tree, which is having different question set for different things. But here, on an average, you have provided a decision tree in such a way that with 3 questions, you have identified all the people who are there. For example, whether they are wearing glasses, no. Whether they are having long hair, yes. Whether smiling, yes. So you will identify this. All the result will come with 3 questions. So let us go with 3. I will show you the bad tree. Now I have shown you a good tree. Let us go for a bad tree. This is the worst situation of a bad tree. That this is the best example. You see, to identify men and women of the same above chart, which you have shown previously, which you have seen previously, is being rewritten with the worst chart. See how many questions on an average here you will ask to identify a single person. What is the maximum question that you have here?
7, sir.
7.
7.
7, sir.
7.
7.
I need to get. I think you need to get 1, 2, 3, 4, 5, 6, 7 questions. So on an average, this will hold something like 4.4 questions per average, right? So which tree is best when compared in these two things? Is it 3 or 4.4 average?
3.
3. The maximum is 3. The average is 3. But here in this decision tree, I think the maximum is 7 and the average is 4.4. When compared to the previous tree, both are equal. The before one is the far better decision tree. So you need to decide what decision tree is the best tree so that your result will be attained as fast as possible. I think you understand which one is the worst and which one is the best. Based on your understanding, I think I will recommend you to always rearrange your decision tree so that you come to your best decision tree. Now tell me, how many of the phases take more than 3 questions to identify with this decision tree? Take 30 seconds to answer and tell.
5, sir.
5, sir.
5, sir.
5, sir.
Is it 5?
5, sir.
5, sir.
How many results are there?
5,
1,
sir.
2, 3, 4, 5, 6, 7, 8 results are there. And in 8 results, I think more than 3 is taken by at least 5 results. And a 5 results ni cherukodaniki, to reach those 5 results, you are taking on an average of 5 questions. This is a very bad decision tree. So the before one is the best one. If you go back, so you can see how good it is. So all the questions can be attained with only, all the results can be attained with only 6 questions on an average. But here you are having at least 5 phases to be identified with maximum number of questions. That means more than 3. So this is how you need to take and write a new decision tree every time. So here in the initial days, you will write a decision tree like this, the worst decision tree. So no problem. You sit quietly, think about it, take another page. Don't look at this one, think newly and write another decision tree in such a way that you will land up to the decision tree which is shown before, which is best one and having less number of decision questions. Now, in this diagram, let us check out. This is the one I am giving you as a decision tree. The next question I ask you is, this decision tree has instructions for distinguishing 6 phases. Which phase will you land on if you use this type of identification? For example, you want to identify this person, okay? And using this person's particulars and information, if you go through the decision tree, please tell me at what phase you will land and what phase.
F.
F, sir. F.
Sir.
Yes,
F, sir.
say F. Okay. Any other answer other than F?
A, sir. A.
A. Okay.
E, sir.
Any other answer other than A and
Sir,
F?
E,
D.
sir.
D, sir. D.
Right.
E, sir.
Now let us go through. So looking at this person, now I want to say whether he is having a brown hair. Is he having a brown hair or
No, sir.
golden hair? This is called blonde hair, right? So no, he is not having brown hair. Let us go to this one. Is he having a black hair?
No, sir.
No, sir.
So naturally, where you will launch it?
F.
You cannot launch it A because he is not having brown hair. It is a gold hair and it is also called blonde hair. It's not brown hair. So if it is brown hair, then you can go to S. But now what happens is you are getting F as an answer. See how bad the decision tree has been given. One thing is very important. Decision tree not only helps you giving the answer, it also should tell you that whatever feature that you have given is not there with me. Edo answer ichchegordu. Did you understand? So for example, you are going to an ATM and you are entering a wrong pin, and even you enter a wrong pin, if it doesn't say any message and say, okay, please choose your money, I'm very happy that something you entered. Ante oppuntaru meeru. Some ఏదో ఒక thief వెళ్ళాడు నీ కార్డు పట్టుకుని వెళ్ళాడు. He took you a card and inserted it into the ATM, and finally he entered some wrong pin. But still, if the computer goes inside and asks the person to enter the money, will you feel bad or not? It will show you a message that you have entered a wrong pin. Yes. Decision making lo prati concept ni meer chaala careful ga aloచింchali. Every case should be clearly identified. For example, if you said that identify this person, if he is not identified, for example, have you seen in movies some criminal photo will be matched among all the photos that are there already in the police database? Have you seen that? For example, they will match with other.
Yes, sir.
If for some criminal, because he's having a beard and he's having a long eyebrows and so, and your photo is coming as matching, how bad you will feel? So it should either say that this person doesn't exist or this person is exactly matched. Is the two things that it needs to give. So here you need to understand that is computer doing a mistake or the person who designed the tree does a mistake?
Who designed the tree has
Who
done
designed
a
is
mistake.
Who designed it has does a mistake.
Done a mistake.
Is very important here. So most of the people in the first year say, sir, I have written program correctly, but the computer is giving me wrong output. Why like that? So why they give? Because it is you who has written the program badly, and because of that, a blind system could not. It's very innocent, it only knows what to do. So here, according to this, you are not giving like if there is no black hair, you should not go to this one. You need to write another condition in such a way that it should say that there is no matching. That is also very important here. Okay. So decision tree should be carefully written with all the cases tested. That is why when software designers want to design some software, they go to the domain. For example, you are designing a railway. For IoT people, I am saying, if you are designing a railway traffic management system, you need to write the program in such a way that the trains should not have any accident, right? You need to observe the domain, how the traffic is being controlled, how the signals are being given, and you need to take the decisions which train should be allowed and which train should not. Now, I think most of the railways are going for softwares, right? They're not having any manual systems. The shifting of track or giving red signal to one train and allowing other train is mostly managed by the software. And if you IoT people who doesn't write a good decision making, the trains will crash like anything, and a lot of accidents will happen in the country with all the trains. So you should be very careful of giving the final result, clearly indicating whether the result can be found or not in this particular situation. I hope you understand. So while you are writing decisions, not only you see that the number of decision persons should be reduced, you also need to understand sometimes there might be errors in the input. If you don't find the result, you should also produce that the result is not found. This is how. So we need to go to F. So you had a wrong output. You had a wrong output. And this is what going with most of your systems. See, general manki A and ML data sciences low, you will have few trainings. For example, you are taking a lot of photos. You had a European tour, for example, and you think that you imagine that there are a lot of green fields in Europe, right? And while you are taking photos, a lot more times you will have sheep or cows that are roaming in the green fields along with horses. So they also will be in the photo. And there is an example that one person has trained all his photos, right? Trained all his photos. And said that these are called green fields. So wherever he is standing, he said, this is me, and the backside is a green field, okay? Because it is all green grass that is there. Okay, one day, after taking all these photos, he was very happy that all the European photos after training, the computer is telling that, okay, you stood at Greenfield, you stood at Taj Mahal in India, you stood at Eiffel Tower in Paris, like that. He's very happy that his computer system is working properly. But one day he went to Texas and he took a photo near a very big farm where only Greenfield is there. There are no cows, there are no cattle, there are no horses. And he came back to India. And he kept the photo into the computer and said, asked the computer, please determine where I am standing. It said that you are not standing anywhere. He was surprised. He was searching why my training algorithm is gone wrong. And he could find the answer. Can anybody find the answer? According to the story, what is wrong he has kept? Can anybody tell me the answer? Did you understand the question? Shall I repeat the question again?
Come again.
So repeat it once.
Yeah. One person from India has gone to an European tour and he took many photos in the green fields. Generally, green field is like a big farm. Okay. In Europe, their farms are very big. They look like parks and green fields, completely with green grass. And along with that, they also freely allow the cows and the sheep and the horses to roam there. So every photo he has taken has horses, cows, and sheep, and that photo was taken as Greenfield. He marked it as Greenfield, and he trained it in the computer. He uploaded all the photos and said all that thing that looks with the green color is a Greenfield. And he said, I am standing there. So you need to identify that I am standing there at the Greenfield. And he also uploaded some images of Eiffel Tower, and he said, whenever I stand here, you should say that you are standing at Eiffel Tower. Like that, he trained. After a few months, he has gone to Texas. He stood near a big farm which is having a green grass and a green field, and he took a photo. With much more happiness, he came back to India and inserted that photo into the computer and asked the computer to determine where I am standing. And the computer gave him the answer that you are standing nowhere. Then he was very bad at his feelings. I tried a lot with a lot of photos, and it needs to say I'm standing at Greenfield. Why is it saying like that? What is the wrong? He has given in the training.
So the animals are missing. The animals contributed. Animals
He
contributed.
might have coded in such a way that if there's any cattle or something, consider it as a green farm.
Yes. He did not give cattle or something, but the problem is he has looked at the photo. The computer started to divide all the different things. Like it divided the sheep, it divided the green field, and it divided the man. And what it thinks is that along with this person, if some needs to be identified as green field, it also have sheep or cattle. That's the problem, right? So whenever you give a normal green field without any of these things, the computer will search for whether sheep is there or not, or cows are there or not, is there or not. Yes?
Your voice is breaking, sir.
So today, all of our internets are not stable, I think. Okay, now is it okay?
Yes, sir.
Yes, sir.
Yes. Of course, your voices are also coming like breaking, but maybe it's a problem with my internet. Okay. Now, when he gives a greenfield photo to the computer, how it trains is it divides the sheep. It also takes this person and also the green field into consideration. So what it thinks is every time to identify a green field, I also need the cattle. This person did not give anything. He only said divide different images, like the green field as one image, the cattle as another image, and this person as another image. And what the computer understood is after dividing them into different objects, let us take them, the combination of all these things will only give me the green field. So when he put only this person standing with a plain green field without any horses or cattle, what the computer understood is it missed the third object. So it is not a green field. Did you understand my example, what I said?
Yes, sir.
Yes.
Yes,
So
sir.
this is a bad decision making. So computers might fall into pits because of this type of training. So as data scientists, you need to be very understandable towards the domain. You need to train it very perfectly. So you need to give a clear condition to it. Whatever objects that you find, but if you find something that is entirely green at the back end, you should identify it like a green field. This is what the clear decision making you should give, not only dividing the objects among them. Right? This is one. So I said this example, which I have given to you. So the other cases computers fail to make decisions are more worrying. Many computer programs real-time facial recognition don't work well with the people of darker skin. The problem is, see, I have many people coming with my projects, fourth-year people. They say that, sir, actually, we wrote an algorithm which is from GitHub. We took a help from GitHub, and it is not identifying our emotions. The problem is, most of the photos trained by the people in GitHub are from Western countries, and they train it with, that white faces. If you give my face and say, okay, Kranti is laughing, it cannot identify because it did not identify by my skin. So you should be looking into different cases while you take the decision making. You need to identify the Americans, you need to identify the red Indians, the blacks, the browns like Indians, and the Chinese, everything. All cases should be considered. Then only your software or decision making tree is perfect. So I think you understood what it is, and in the next classes, you will go for algorithms and pseudocode, how to write in a computer language, computer understandable language for these decision trees. So I think if you understood this topic and the importance of this topic, you click yes and click next. Have you understood the topic, what I am trying to tell you?
Yes.
Yes, sir.
Yes, sir.
So now we should fill the Google forums, sir. No.
Yes.
Now we should fill the Google forums, no, sir. No.
Yes, that's all. You click S and next. That's all. It will send the form to me.
10 o'clock.
Until now, whatever you are clicking and saying next will always be submitted in the Google form. And final next year, if you understood the topic, will finally send you submit your form.
Submit. Yes, sir. It's asking.
Yeah, Nikhil, what confusion you are facing? Oh, what should you press? In the form you are telling, not about the topic, right? So if you understood the topic, click yes. If you don't, you click no. You'll get back to the first page, I think. Have you understood the topic at least, Nikhil?
No.
Nikhil, are you? At least type in the message. You understood the topic?
No.
You did not? No. So where did you? Okay. Where haven't you understood? Okay. A bit confusing. So where did you confuse? Can you tell me?
Alert from update available.
Nikhil, I want to ask you, where did you confuse so that I can clarify it in the next class? Possible. Okay. So how to answer? Okay. Anyway, when we come to Raptor, you will have an understanding between them. No problem. Okay. How to ask questions? No problem. When you go to Raptor, we will discuss few examples where you can reduce the number of questions, and definitely you will understand it. But I think at least you got the concept of how the questions can be posed and how to reduce the number of questions and how to go for good decision trees. Okay, so that the minimized questions will give you the final result as early as possible and as fast as possible. If you understand that one, it will be fine. You can look into these examples once again. The form will be there with you, and you can also go through the form. Okay, fine. Thank you all. Bye bye today.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Sir, can I wind up the session?
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.